Hi guys, today we're looking at calculations involving heat. So let's just go over our steps again. When we're looking at calculations involving heat, we must draw a diagram, write our energy lost is equal to our energy gained, and then when dealing with these questions, we need to think about where is the heat being given out, either by change of state or change of temperature, where is the heat being absorbed, either by change of state or change of temperature, and try not to miss any part. Remember that a change of state is given by E is equal to Lm, and a change of temperature is found by E is equal to mc delta T. Okay, so we're going to try exercise 15.2, question 11. We're told that 2 grams of steam at 100 degrees Celsius are added to an insulated calorimeter containing 80 grams of water at 10 degrees Celsius. Find the resulting temperature of your mixture. All right, so in this case, draw out what you have first. So we have water, and our water is at 10 degrees. We then have steam. Okay, so we have steam, which is at 100 degrees Celsius. And we're adding steam to the water. As we add steam to the water, our water will heat up as it takes energy from the steam, which changes state into a liquid. So as your steam is added to your water, your steam condenses. So our steam is going to change into water, and all of that energy is then given to our water, and our water heats up. Okay, so we want to find the temperature that the water heats up to. We start off by stating that the energy lost by one system is equal to the energy gained by another system. This is due to thermal equilibrium. So our steam is losing energy, and our water is gaining energy. Our steam is changing state from a gas to a liquid, and our water then takes this energy and heats up. So where is our energy being lost? Our energy is being lost by the steam changing state. And where is energy being gained? So this steam changing state loses energy, and all of that energy as it changes state, so as it loses all of that potential energy, all of that energy is given to the water and it heats it up. So energy is being gained by the water changing temperature. Okay, so from here I find where my energy is being lost and where it's being gained, and whether energy is being absorbed or given out by a change of state and change of temperature. We now substitute in our equations for change of state and change of temperature. So if our steam is changing state, the amount of energy lost is equal to Lm. Our water is heating up, so there's a change in temperature. So our water is gaining energy by mc delta T. Our latent heat is the latent heat of vaporization. This is because our steam is changing into water. Therefore, our steam is going from a gas to a liquid. From here, we just substitute in the values that we know and solve for our unknown. Our latent heat of vaporization is 2.3 times 10 to the power of 6 times the mass of your steam. So my mass of my steam is equal to 2 grams. Don't forget, you must convert this value into kilograms. To do that, we divide our value by 1,000. This gives me 0.002 kilograms. Now, to find MC delta T for the energy gained by the water, we need the mass of our water. The mass of our water, we're told, is 80 grams. Converting this into kilograms gives us 0.08 kilograms. Times C, our specific heat capacity of water, which we're given, 4,180. Times our change in temperature. We are trying to find what the final temperature of the water is. We know the initial temperature was 10 degrees. Our change in temperature is therefore our final temperature minus 10. From here, we solve for our unknown. So multiplying out our values, 2.3 by 10 to the power of 6 times 0.002 gives us 4,600. This is equal to 0.08 times 4180, which gives us 334.4 times our final temperature, which we want, minus 10. Let's keep expanding and solving. I have 4,600 equals. So here I must multiply 334.4 by everything inside my brackets. This gives me 334.4 TF minus 3,344. I want to find my final temperature on its own, so I'm going to have TF on one side of the equation and everything else on the other. Okay, so I'm going to add 3,344 to both sides of my equation. I get 7,944 equals 334.4 times my final temperature. I want my final temperature on its own, so I now divide by 344.4. Sorry, 334.4. This gives me my final temperature of my water. It's 23.76.